Today we're going to be talking about multiplying polynomials, and in particular, multiplying polynomials is going to require a strong command both of the distributive property and how exponential multiplication works. So without further ado, let's kind of get into this. So recall the distributive property means that if I have a number out in front of a parentheses or a number with some variables, that I can go ahead and distribute multiplying that across any addition or subtraction that's inside those parentheses. So for example, since 6 times 3c gives us 18c, we're good to go. 6 times 7 gets us 42. Therefore, 6 times parentheses 3c plus 7 must be 18c plus 42. If there's a negative out in front of those parentheses, that distributes as well. So for example, negative 3b times negative 2b will end up with negative 6b squared, with us knowing that b times b becomes b squared since b has been multiplied by itself twice. And negative 3b times negative 5y is going to become positive 15by. So recall that a negative times a negative will have to be a positive, so keep track of that as well. I'm going to go ahead and encourage you to pause your video and try these next three yourselves before we go through them. So for these next three, recall that if there's just a negative chilling in front of the parentheses, that's secretly being multiplied by negative 1. So negative 1 times positive 5c will give us negative 5c. Negative 1 times negative 2b will give us positive 2b. And negative 5c and 2b are not like terms, so we're going to leave them as is. Similarly, negative 3 times positive 2k will give us a negative 6k. Negative 3 times a negative 9 is going to get us a positive 27, since a negative times a negative is a positive. And again, no like terms to combine. If we have a 5x times an x, that's going to give us 5x squared, since x times x is x squared. And then 5x times negative 4y will give us negative 20xy, because x and y are two different bases, so they're not going to combine to make any sort of exponent. If we have a polynomial times a longer polynomial, it's the same idea. We can just continue the distributive property by however many terms there are. So whenever you're distributing, keep in mind in terms of exponent rules that if, for example, I was doing a 4x squared times a 3x squared, that becomes 12x to the fourth because I've done x squared times x squared, so a total of 4x is being multiplied by each other. And similarly, if we have 4x squared times 4x, which I don't know why that line's being so long, 4x squared times negative 4x is going to give us a negative 16x cubed, because if we have two x's times one more x, that becomes an x cubed. Now let's try some more practice questions here. So in particular, don't forget that we can actually distribute over all three terms. So if we, for example, in this first one, do x to the fourth times x to the fifth, that's going to leave us with x to the ninth. X to the fourth times 8x to the third will leave us with plus 8x to the seventh, since 4x's times 3x's gives us 7x's. And then x to the fourth times negative x to the first, if you see just a negative x that's related to the first, gives us minus 5x to the fifth. And that would be our final answer. So go ahead and pause your video and try these next two yourself before we go through them. So if we're going to keep going, if I have 2x to the second times 9x to the fifth, that will leave me with 18x to the seventh. So we're still multiplying those coefficients, but we end up adding those exponents because we're depicting that repeated multiplication. Then 2x to the second times 3x to the third will leave us with positive 6x to the fifth. Since if we have 2x's times 3 more x's, that gives us 5x's. Then if we have 2x to the second times negative x to the second, that will leave us with negative 14x to the fourth as our final answer. And then for our final piece of distribution, if we do 2x to the second times 8, that will give us positive 16x to the second. Now it's always worth double checking that you should have as many terms as you have terms in parentheses, and that's exactly what we have here, so we are good to go. And then for this last one, positive x to the fifth times 32x to the third will leave us with 32x to the eighth. Then positive x to the fifth times x to the second will leave us with positive x to the seventh. X to the fifth times 8x will leave us with positive 8x to the sixth. And then x to the fifth times 19 will give us positive 19x to the fifth. We're going to have a few more terms to keep track of if we have a non-monomial times another non-monomial. And what I mean by that is if there's multiple terms in both parentheses. So let's start with a binomial times a binomial. So a lot of times for this, the way that people remember is that you're going to do FOIL. So first you do the first terms, then you do the outer terms, then you do the inner terms, and then you do the last terms. In some way or another, you should be doing each term times each other, and you'll know you did it right because you'll have 2 times 2 is 4 terms left at the end. So that's ultimately how you know you do it right, is that you do the number of terms in each polynomial times each other. So in this case, 2 terms times 2 terms, there should be 4 terms there when you're done totally foiling it out. So let's go ahead and go through some examples. So if we have x plus 2 times x minus 7, for example, x times x gives us x squared. Then if you do x times negative 7, that will give us negative 7x. Then 2 times x gives us 2x. 2 times negative 7 gives us negative 14. And typically when you do this, you might end up with some like terms there, particularly in the center. In this case, negative 7x and 2x made us negative 5x. So that's usually an extra step that we didn't have to do last time, is double check, are there like terms? And occasionally those like terms will even cancel out, like in this next case where I do 8x times 8x, great, that's 64x squared. 8x times negative 6 is negative 48x. Positive 6 times 8x is positive 48x, and 6 times negative 6 is negative 36. But then those negative 48 and positive 48 combine to make 0, because negative 48 plus positive 48 is 0. So that's why you're only left with those 2 terms there at the end. I'm going to go ahead and encourage you to pause your video and try these next 4 yourself, and then we'll compare. So for these, if you do x times x, that's going to give you x squared. X times negative 5 gets you negative 5x. 3 times x gets you positive 3x. 3 times negative 5 gives us negative 15. I know I did it right because I have 4 terms and I have arrows going to each combination. Negative 5x plus 3x is going to give us negative 2x. Drop down everything else, and then we are good to go. And knowing how to do this in particular is going to be super helpful for factoring, because factoring is where we work the other way around. So if I gave you something like x squared minus 2x minus 15 and you want to make the parentheses, you're working backwards here. So knowing how to work forwards is going to help you out a lot for working backwards. Let's go ahead and keep going though. 5x times 3x is going to give us 15x squared. 5x times negative 8 is negative 40x. 2 times 3x is going to give us positive 6x, and then 2 times negative 8 will give us negative 16. Negative 40x plus 6x is going to combine to make negative 34x, and then everything else is going to drop down. This next one, if we keep going, 3x times 3x is going to give us 9x squared. 3x times negative 2 is negative 6x. 2 times positive 3x is plus 6x. 2 times negative 2 is negative 4. Negative 6x plus 6x makes 0, so we're just left with 9x minus 4. Now this pattern that's going on here in the center we're going to touch on again at the end of the video, because there's actually a very special pattern that consistently happens whenever the terms match, except for the plus minus there in the center. It's going to make those center terms always cancel out, which is known as a difference of squares. So that's always something worth being cognizant about. But this next one's not a difference of squares. Let's just keep on going. If we do 4x cubed times 6x cubed, that will give us 24x to the 6th, because that's 3 x's times 3 more x's. 4x cubed times 1 gets us positive 4x cubed. Negative 2 times 6x cubed gets us minus 12x cubed. And then negative 2 times 1 gets us minus 1. 4x cubed minus 12x cubed will combine to make 8x cubed. And then we're just going to drop down everything else, and that will be our nice, beautiful final answer. If we have an even more complicated polynomial for the second term, I would highly recommend vertically aligning your terms as you go, because now you're going to have a lot more terms to keep track of. In particular, if you do this right, you'll have 2 terms times 3 terms in this example here to keep track of. And I really should have given myself a little bit more room there, so I'm actually going to kind of just shimmy this off to the side for this example. So if I have b plus 3 times 2b squared minus 5b plus 8, the way that I'm going to do this is I'm going to completely FOIL out all the terms, and I'll know I did it right because I'll have 6 terms there at the end. So if I do b times 2b squared, that will give me 2b to the third. b times negative 5b will give us negative 10b squared. b times 8 is going to give us plus 8b. And then I'm going to keep on going, and I'm going to kind of change colors, keep on going. 3 times 2b squared is going to give us positive 6b squared. Notice how I went ahead and vertically aligned it with my other b squared term. 3 times negative 5b is going to give us minus 15b. And then 3 times 8 will give us positive 24. And now I'm ready to add these straight down. 2b cubed is the only of its term. Negative 10b squared plus 6b squared is going to give us negative 4b squared. 8b minus 15b will give us negative 7b. And then the 24 is going to stay as is. And that would be my final answer for that example problem. So apologies on not giving you much room to write there. Hopefully you were able to kind of shimmy off to the side just like I did. So with that in mind, I'm going to encourage you to go ahead and try these next 2 problems yourself, trying that vertical alignment trick, and then go ahead and start your video again to see how you did. So for this first one, again, I'm going to keep track of this vertically. If we have x times negative 6x squared, that'll be negative 6x cubed. X times negative 4x will give us minus 4x squared. X times negative 12 gets us minus 12x, and then we're going to keep on going with the next set of terms. Negative 2 times negative 6x squared will give us positive 12x squared. Negative 2 times a negative 4x is going to give us positive 8x, and then negative 2 times negative 12 will give us positive 24, and then we're going to add straight down. So negative 6x cubed is already by itself. Negative 4x squared plus positive 12x squared is going to give us positive 8x squared. Negative 12x plus positive 8x will give us minus 4x, and then there's no other like terms with the 24, so he's going to drop straight down. For the next set of terms, same idea. So if we're going to have a 8n squared times a 5n, that will give us 40n cubed. Again, multiplying those coefficients and then using exponent rules to multiply those variables. 8n squared times negative 3, and I just sort of covered up the previous answer, so let me shimmy this a little bit more carefully so I'm not covering that up. 8n squared times negative 3 is going to give us negative 24n squared. And then we want to keep on going. Negative 9n times 5n is going to give us positive 45n squared. Negative 9n times 3 is going to give us positive 27n. And then we're going to keep going with the last set of terms. 6 times 5n is going to give us negative 30n. 6 times negative 3 will give us negative 6 times negative 3. That's negative 6 times positive 5n for negative 30n. Negative 6 times negative 3 is going to give us positive 18. And now we're ready to add straight down. And I know I did it right because I had 3 terms times 2 more terms. I should still have 6 total terms before simplification, which is what I have. 40n cubed is just going to drop straight down. It has no like terms. Negative 24n squared plus 45n squared is going to make positive 21n squared. 27n minus 30n will give us negative 3n. And then the 18 has no like terms, so he's going to just stay exactly as is. So some patterns that come up pretty frequently is if you have a perfect square, make sure that you're FOILing out multiplying that term by itself. So if, for example, you see x plus 5 all squared, you want to go ahead and rewrite that being squared means I'm doing x plus 5 times another x plus 5. And then as you FOIL that out, you'll have x times x to give us x squared. You'll have x times 5 to give us 5x. 5 times x to give us 5x. 5 times 5 to give us 25. And then those two terms in the middle will combine to make 10x. Similar deal here. So if I have x plus 3 all squared, I'm going to rewrite that as x plus 3 times another x plus 3, which means I've got x times x to make x squared, x times 3 to make a 3x, 3 times x to make another 3x, and 3 times 3 to make 9. And then those two middle terms combine to make 6x. Notice how I didn't just distribute the squaring over the x and the 3. I am not allowed to distribute an exponent over addition. You are allowed to do it over multiplication, so if I have 3x squared, that does indeed equal 9 times x squared, because 3x squared, recall, means 3x times 3x. But if I have x plus 3 squared, that's an x plus 3 times another x plus 3, which means I have to FOIL it out. You're not allowed to just jump to distributing it. For this last one, same deal. So we're going to rewrite that as 5x plus 6 times another 5x plus 6. Then we're going to totally FOIL it out. 5x times 5x gives us 25x squared. Don't forget to also multiply those coefficients. 5x times 6 gets us plus 30x. 6 times 5x gives me plus another 30x. 6 times 6 is going to give us plus 36. 30x plus 30x will combine to make 60x. I'm going to drop down the 25x squared, drop down the plus 36, and bada boom, that's our nice, beautiful final answer. You'll often notice this is the general pattern whenever you have something times itself like that, where you will have the first term will be the first term squared. The middle term will end up being double the first term and the second term multiplied by each other. So 5 times x is 5x, doubled is 10x. 3 times x is 3x, doubled is 6x. 5x times 6 is 60x, doubled is 30x, doubled is 60x. And the last term will be that term squared. I would caution against just memorizing this, though. I think it's worth just FOILing out each time. But knowing this pattern will help with completing the square down the line. Another pattern that often happens is this difference of squares pattern. And what I mean here is instead of having an x plus 1 times an x plus 1, it's not x plus 1 squared, but they're basically the same term with just the addition subtraction sign flipped. And that's going to consistently make the middle term cancel out. And let's see what we mean. So if I do x times x, that's x squared. X times negative 1, that's negative x. 1 times x is positive x. 1 times negative 1 is negative 1. And oh my gosh, the middle terms cancel to make 0, and I'm just left with x squared minus 1. Same deal here. If I do 9x times 9x, that would give us 81x squared. 9x times negative 3 gets us negative 27x. Positive 3 times 9x gets us positive 27x. 3 times negative 3 gets us negative 9. And then lo and behold, those middle terms cancel again to make 0. And then last but not least here is you do 2x times 2x would give us 4x squared. 2x times negative 7 is minus 14x. 7 times 2x becomes positive 14x. And 7 times negative 7 gives us negative 49. Negative 14x plus positive 14x makes 0. And I'm left with positive 4x squared minus 49 as that final answer. A mistake people often make is they forget to also square the coefficient that's attached to the first term. Don't forget that you want to do that too. And then that will allow you to recognize this general difference of squares pattern, which is going to say that if they are conjugates, that's the word for one being a minus b and the other one a plus b, whatever a and b happen to be, then it will always end up as the difference of their squares. So it will be the first term squared minus the second term squared. And that will be helpful for factoring in order to memorize that general pattern.